Okay, now this is a part two of the video that uh, yeah, I made it while I'm away. Or it's to cover for because I'm away. Now, it's about the consecutive reaction. This is part two of today's lesson. Now, consecutive reaction is this. They say in some cases we deal with chemical reaction that requires a series of at least two or more chemical reaction. The series of these reactions are called consecutive reactions. So at this point in your chemistry or science career, you probably are only dealing with reaction that goes one step. So you probably go from reactants to product, and that's it. Now, more complicated reactions or processes a lot of times go through multiple steps. So, for example, for you biology students, recently you're learning things like, cellular respiration, where you have one glucose going to two pyruvate, and then your pyruvate is going through another set of reactions that creates other stuff. If you're on the HL, then you learn like, pyruvate, each pyruvate makes one acetyl CoA and so on and so forth. So this type of consecutive reactions, you also will see that in chemistry too. Later on in our course, when we talk about things like Hess's law, when we talk about rate limiting steps, you will see this type of idea. Okay, so it is a chemistry idea too, but it's not difficult. It is really just following the trail. Okay? You're following the trail, and it's actually somewhat easy. So let's do this together. So in this particular example, acetylene gas, C2H2, is an important raw material in the production of many important chemicals such as synthetic rubber, alcohol, etc. It may be prepared from limestone, CaO3, coke, C, and water according to reactions. So as you can see here, there are three reactions. By the way, this delta here means heat is used. Okay? Assuming an excess of all other reactants, how many grams of C2H2, so this is C2H2, and they kind of tell you is ready, at STP can be obtained from 50 grams of this. Okay? So right now, basically they gave you the amount or quantity of um, this substance, calcium carbonate, and they want you to find the mass produced as C2H2. So as you can see, it's not direct step, right? You have to make this first, and then so basically, I'll use a different color. I'll use a pencil. So in this case, you have to. So basically, the calcium carbonate will be making the calcium oxide first. So after you find out what the calcium oxide, you know that the calcium oxide is gonna make calcium carbide, okay, CaC2, and then calcium carbide it's going to use to make this. So essentially, you're really just following from how much of this product is made, and the amount of this product made is going to be figure out to find the amount of the next product. Okay, so here we go. Now the game plan, what you need to do is this. Game plan, step one, you want to find the number of moles, convert mass to mole of CaCO3 because we know that already, right? Step two, use mole ratio to find from CaCO3, you want to find CaO, moles of CaO. Now, some of you who are kind of like seeing how this whole thing will go you might be flying forward, and it's like, oh, why don't you just directly find this? I'm just gonna do it step by step. Okay. You use the first equation to find the mole of CaO. Next step, you use the second equation because the number of moles of CaO can also help you find the number of moles of CaC2. So use mole ratio to find the number of CaC2. Okay. Last but not least, you use the third equation using mole ratio again to find from CaC2 to find the mole of this. Use mole ratio to find number of moles of C2H2. Now, last but not least, you're going to use the mole of C2H2 to find, because they're asking in grams, okay? I know they say STP, but they're not asking for volume, so just calculate in grams. So in this case, convert number of moles to mass of C2H2. Okay, so here we go. Let's do this. So we have 50 grams of CaCO3. Okay, so in this case, we have to convert step one, convert mass to mole. So molar mass of CaCO3 will be, I didn't pre-calculate this unlike last time, so Ca mole calcium. So calcium, they will give me, oh look, the molar mass is 40. So 40 plus carbon is about 12.01. We've been dealing with carbon so much, we memorize it. Plus oxygen is 16, so 3 times 16. So in this case, close bracket. So in this case, you have what? 52.01 plus 48. That adds up to, looks like 100. 100.01. That's the molar mass of calcium carbonate. Such a neat, nice number. Oh, sorry. You didn't see this. Yeah. So in this case, mole equals mass divided by molar mass. So in here, 50 divided by 100.01. This is 0.5. Okay? Pretty much 0.5. I know it's not exactly 0.5, but hey. 50 divided by 100.01, then there you go. Yes, don't be lazy. 0.49995. Okay, let's keep that. So that's the number of moles of calcium carbonate. Okay, now second step, use the mole ratio to find the number of CaO. Now if you look at this, calcium carbonate and the molar ratio between this and this is really 1 to 1. Because it is 1 to 1, ratio, then in this case, the number of mole of CaO is also happen to be 0.49995 moles. Now, this is only the example, so of course numbers are going to be that easy. That's why I kind of do everything, broke out everything in steps. Now, next part, again, you use the mole ratio to find the next one. So look again, this is also 1 mole to 1 mole ratio for CaC2. So again, number of moles of CaC2 is also 0.49995 moles. Okay, if it is not 1 to 1 mole, you will have to kind of do cross multiply, but it is not. It is just 1 to 1. So there you go. Again, next step, use mole ratio to find this. Again, yay, it's 1 to 1. Awesome. So in this case, number of moles of C2H2 happens to be also 0.499950. Okay? Now, last step, convert this to mass of this. So, it's C2H2. So, again, you need the molar mass of C2H2. There's 2 carbon. Carbon is 12.01 plus 2 hydrogen, which is 1.01, which in this case was 24.02, 2.02. This is 26.04. 26.04. Now 26.04, that's molar mass. Mass equals number of moles times molar mass. So in this case, here you have right, 0.499950 times 26.04. That should give you, put that in the calculator. Do you guys hear the whole thing next door? If you don't, that's okay. Better that you don't hear it. 13.0186. Okay, so that is, now that's the mass. So that's the mass of the acetylene. Now I know if you do sig figs, it's 1 sig figs. That's ridiculous, but we're just learning the concept, okay? And on the test, we're not going to give you silly numbers like that. So that is the mass of C2H2. So again, look through this carefully. If you want to take a picture, go ahead, do that. Keep in mind, we might not be so nice and always go give you the start thing from the bottom. I think in the next example is slightly different. So do this practice question and enjoy. Okay? Yeah. Practice and enjoy. Bye.